Hi, back again. Dr. Bones talking a little bit about vectors earlier. Here in the connection with pulleys, I've got a pulley system here. By the way, this is called an Atwood machine. Got a couple of 5-pound plates here, actually 2.5-pound plates, 5 pounds total, but they're equal masses. So in this case, I've got mass 1 and mass 2, we could call it tension 1, tension 2. And tension 1 and tension 2 are going to be equal in this case. The two masses are the same, the two weights are the same, the tension is the same. In this case, weight equals weight, tension equals tension. What is the net force here? I've got a tension minus the weight, tension minus the weight, net force is 0. Not moving anywhere. Now if we change something here, I could add more mass here, this would start to pull down, or I could just add a force. For example, I'm going to hold down. So the force is going to be down, or I could say let's push it up. Doesn't really matter. The tension is going to be the same, but in this case we've got an acceleration. We've got an acceleration downward for the one weight. We've got an acceleration upward for the other weight. So for example, I can say I've got a vector acceleration for this pulley, or this weight I should say, and a vector for acceleration in the opposite direction. Okay, so this is an Atwood machine, kind of interesting for moving things around. All right, so a simple Atwood machine. We said that the unequal masses would involve unequal forces. So the net force is going to be some positive value force instead of a net force equals 0. So as we change the forces, something happens. Okay, there you go. All right, wanted to show you another Atwood machine. Call this the Actually, let's try one here with unequal masses. Again, it's kind of easier with two equal masses and then adjust the force. I'm going to have to take this clip off here for a second, so bear with me. Probably easier to do than hanging the pulley on here. All right, there we go. These are kind of neat. So when you put these together, you don't have to worry about this thing falling apart. So I've got the horseshoe clip here. I'm going to put this on. I've got two unequal masses back on the pulley. Obviously, I have two unequal masses, one bigger than the other. Let's put some support here. So one mass bigger than the other. Obviously, a directed force, acceleration upward and downward. Got something that will help with the crash at the bottom. So again, Atwood machine with unequal masses. I didn't really want to do this with too heavy a weight. That's why I adjusted the equal masses earlier by just pulling harder on one. So here you put a bunch of smaller masses on, and there you see it. So you've got the acceleration upward and downward with the unequal masses. Here's another Atwood machine. It's called a double Atwood machine. And again, I'm going to have to hook up the horseshoe clip here. These are kind of fun. I wish I could afford buying more of these horseshoe clips, but let's put that on here. And this will be ready to go. This is the double Atwood machine. Kind of neat. And you can play around with the mechanics on a machine like this, for example. You just hook this up. This is called a double Atwood machine. Obviously, it's got two pulleys. Okay. By the way, when you're doing these calculations, for example, in a physics class, when they talk about the Atwood machine or the double Atwood machine, they'll be telling you what the size is of the masses and so on. The approximation is going to use a pulley with a certain mass, okay, another mass here. But in the ideal situation, we talk about massless pulleys and frictionless pulleys. So kind of unrealistic to think about it that way, but useful in doing simple problems. So with the ideal situation, we say massless pulleys and frictionless pulleys. So we could, for example, put together, a problem here. I could say 8 kilograms here, 4 kilograms here, 5 kilograms here, and find out exactly what the tension forces are and so on with this double Atwood machine. So in the real world, we have mass pulleys that weigh something, and they have friction, of course. Kind of interesting. So there you go. All right, be back in the next segment. See you then.